Alright, welcome to video number 19. If you are watching this, that means you finished your Chapter 2 test and you are getting ahead for Chapter 3. So good job there. Hopefully that all went well. So we're doing today, starting our next chapter, this is Systems of Equations. If you're in Algebra 1, you've seen it before, we're going to do the same thing but go a step or two further. But in case you have forgotten, this is what a system of equations is. Here's the definition right here typed out for you. It's just a set of two or more equations that use the same variables. That's the book's definition. All that means is you have two or more equations, in this case right here I have two, that you're solving at the exact same time. And usually if you have two equations, then you have to have at least two variables. So what you're trying to do is you want to find the values of x and y, this one has x and y, that make both equations true. That's the goal of this whole entire chapter. Today we're going to look at one way you can do that. So let's look at this system again. So here's that first system. We have y equals x plus 3, and the other equation is y equals negative 2x plus 3. Well, first off, in the next two chapters, we're going to learn about 4 different ways we can solve a system like this. So two equations, two variables, sometimes you have 3, spoiler alert, Algebra 2, baby. So there's 4 ways to solve these systems. We're going to look at method number 1 today, and that is by graphing. We just finished chapter 2, which is all about graphing. So of course, no surprise, the first thing you do in chapter 3 is more graphing. So we can solve this system right here by graphing. Let's do that right now. So what I want to do here is just take my equations, graph both of them, and find the intersection. The point where they touch will be my answer. So first off, the first equation, y equals x plus 3. So I'm going to start at 3, and my slope is 1 over 1. So I'm going to go up 1 over 1. This graph looks something like this. I'm going to do my best to draw it neat. When you do this yourself, graph as many points, or plot as many points as you can before you take your straight edge and graph it. And the one in green, negative 2x plus 3. So I again start at 3. This time it's down 2, right 1, down 2, right 1. The slope is negative 2. I'll also go up 2, left 1, go backwards. So this one looks something like this. So where do they intersect? Well, right here. This one was probably somewhat obvious because they had the exact same y-intercept, so of course they meet there. So the point they meet, x is 0, y is 3. That right here is the solution. That's the point. So x is 0, y is 3. And you see it over here too. 3 equals 0 plus 3. Well, that works. 3 equals 0 plus 3, because 2 times 0, well, negative 2 times 0 is 0. So, yeah, this right here checks out both of these. So number 1 is done. Let's go on to number 2. So now I've got these two equations, x plus y equals 4, and y equals 2x plus 1. I can't quite graph them yet because in this top equation in blue, y is not by itself. So I've got to fix that. Get y by itself. So I'm going to rewrite this as y equals negative x plus 4. Right? I just took from both sides, subtract x. So now I've got this equation here. Y equals 2x plus 1. I'll call it my number 1 equation. My number 2 equation, I had to rewrite it so y is by itself. And I get y equals negative x plus 4. So make sure in both of these, when you graph them, you've always got to get y by itself, isolated. We did this for the last 2 chapters. We still do it. So I'm going to go up a little bit here, and now I'm going to graph this. So I'm going to draw these axes out. Again, I'm using an iPad, so it looks kind of sloppy. You'll use a ruler and some nice graph paper, so it looks perfect. So the first one, 2x plus 1, start at 1, my slope is 2, so up 2, right 1. I'm going to show these points, go backwards a little bit. So I have all these points, and like I said before, plot many points. Plot as many points as you can fit on that graph before you actually graph it. Because again, the more points you plot, the nearer the graph is going to be. Here we have to find the intersection by graphing. So I'm going to graph this one now. Negative x plus 4, so start at 4, and the slope is negative 1. Since I'm solving by graphing, if I don't graph these neatly, I'm not going to get the correct answer. So it's incredibly essential that you graph with care, use rulers, graph paper, make it neat. If you just draw this in your notebook and it looks all sloppy and crappy, you're not going to get the answer, and you just waste your time for no points. So anyways, I graph both lines. My answer is right there. That's the point, 1, 3. So what that means is x is 1, y is 3, and that's my answer. And what I can do is check it up here. So if I check the first equation, I'll check the one up here originally. So 1 plus 3 equals 4. Well, that's good. And then 3 equals 2 times 1 plus 1. 2 plus 1 is 3. That's good. So we're good. This is the answer. I don't care which way you give me the answer, as a point or like this, just give me the correct answer. How about example 3? So in this system, we're going to level up a little bit. 3x plus 2y equals 7 is the first one. 3x minus 15 equals negative 6y is the second one. In both of these, what do you notice? Y is not by itself. So I've got to do just this over here, isolate y. So for both of these, I'm going to do that right now. So rewrite both equations down here so I have space to work with. And now I've done all the work for you here, so you can see with the blue equation, from both sides subtract 3x. I'm here. Then from all three parts divide by 2. So y equals negative 3 halves x plus 3.5. In the green one, there's just one step, right? Divide by negative 6. Get rid of that negative 6 up here. So when you do that, you get just y equals, this becomes negative 1 half x to 3 over negative 6. And then negative 15 divided by negative 6 becomes a plus 2.5. So now I'm going to graph these two equations here. So again, now I just graph this. So the one in blue, start at 3.5, so right there. Down 3 over 2, there's another point, there's another point, go backwards, there's another point. So this line looks something like this. Let's try that again, making me better. The one in green, start at 2.5, and the slope is negative 1/2, so start right there. Down 1, right 2, down 1, right 2, up 1, left 2. And when you plot a bunch of points, you can already kind of see when it's going to intersect. But anyways, I'm just going to connect these now as best as I can with this iPad. And that's ugly, but that'll do. So my intersection appears to be right about here, which I'm going to say that's 1, 2. That's the point where it intersects, which means your answer is x equals 1 and y equals 2. Let's go ahead and test them out. So test out the first equation. You have 2 equals negative 3 halves times 1 plus 3.5. That means that 2 equals negative 1.5 plus 3.5. That's good. We can then test this one. Plug in 2 for y, plug in 1 for x, make sure it works. Do you have to always plug them in? No. But when you do, you can be certain that they're right. So does 2 equal negative 1/2 plus 2.5? Well, it does. Both these are good, which means then that this is your answer. And again, I don't care which one you get. Which one you give, I mean. 1, 2, or x equals 1, y equals 2. Either one of these, I'm fine with. You're correct. Alright, 2 more examples, and then we're done. So we have another example like the last two. In this one, I gotta get both equations to isolate y. So we gotta fix both of these here. So x plus y equals 6, which means subtract x from both sides. This is the first one. So then you get y equals negative x plus 6. That's the first equation. The second one, I'm going to rewrite it over here so I can work with it. So then from both sides, subtract 3x. So 3y equals negative 3x plus 3. Then to both sides, or all three parts of this equation, divided by 3. So you have y equals negative x plus 1. So I've got these two equations now. The same two I started with up here, just now I've got y by itself. So again, make sure you always get y by itself. So again, let's graph these. So negative x plus 6, I'm going to start at 6, the intercept, and then it's down 1 over 1. So here are my points, somewhere over here. Go ahead and connect this line. It looks something like this. And the one in green. Start at 1. The slope is also negative 1. So my points are over here. So then connect that. So where do these two lines intersect? What you might notice is that these lines are parallel. And you can probably see it from their slopes, right? Both of these have a slope of negative 1. So these lines will never intersect, which means your solution does not exist. So this would be no solution. This will happen sometimes. You will oftentimes get no solution. Anytime your lines are parallel, it means they'll never intersect, there'll be no solution. So, just a little side note here. If you have parallel lines, then you always have no solution. Your book defines this as inconsistent. I'm not too worried about the vocabulary word there. If you can say no solution, you're just fine. So you have something like this, where your two lines go in the same direction, and will just never touch. Right? So there's no point where these two equations are both true, because the lines that represent them never intersect. There's another special case, which I'm not going to show in the video, but will happen in your homework, which is that you might graph the same line twice, which means when you get both equations to isolate y, you get the exact same equation twice, same slope, same intercepts, which means these two lines intersect infinitely, right? They're the exact same lines. They intersect always, which means then you'll have infinite solutions. This is called dependent in your book. Again, I'm not concerned about the definition the book gives you. If you can say infinite solutions, then that's all I care about. The other case is when you have different slopes. So what the first three examples had, right? If you have different slopes with each line, then they have to intersect, which means then that you have, like the first three examples, one solution. So there's always three types of cases with systems. Either you have parallel lines that have no solution, the same line twice, infinite solutions, that will happen at some point, or different slopes. This is the most common case, which is when you have one solution. Okay, so that's it for the graphing of basic lines. We have one more example I want to show. This one involves linear regressions. So here's a real-world application problem based on systems of equations, where the spreadsheet shows the monthly income and expenses for a new business. You see each month of the year, what they make, what they spend, what they make, what they spend. You see they keep making more and more, they keep spending less and less. So at some point, your income will equal expense, which is what you want, so you can start at some point turning a profit. First thing you gotta do is find a linear model for the income and one for monthly expenses. So that's two different models you have to find. So what I'm gonna do here is this is gonna be x, this is gonna be y1, this This is going to be y2. So I'm going to make two different equations here. Well, first off, I need to turn these numbers, or these months, into numbers for x. So I'm just going to turn the months into the number of the month they are. So May will be 5, June 6, July 7, August 8. So now what you're going to do is in your scatter plot on your calculator, you're going to type in this table here. So you're going to have 4 rows and 3 columns. So you're going to have list 1, list 2, list 3. So make sure on your calculator you have list 1, list 2, list 3. So this time we have 3 things to type in. Let's go ahead and do that right now. When you do that, it should look something like this. So now from the data over here, I've created a 3-column table over here. So I need to find 2 linear models. One for this one here, and one for this one here. So first I need to make a linear model for the income column. So I want just list 1, list 2. So in order to do that, I have to hit the linear regression button like before. So of course stat, calculate linear regression, but don't press enter just yet. You're going to specify which columns to use. So you're going to hit second 1, that's L1, that means list 1. Then hit the comma button. There's a comma right there. Then second 2 for list 2. Now press enter, and you'll get your linear model. So your first model based on income should be this one right here. Y equals 2000x minus 8500. So that's your slope, 2000, and your intercept, negative 8500. Now do the same thing, but this time for expenses. So you want list 1 and list 3. You want to use those 2 lists for your regression. So now on your screen, it should look something like this. Again, hit linreg, stat, calculate linreg, but now hit L1, so second 1, comma, second 3, so list 3. Now your machine is going to use the first list and the third list to make a regression. Then press enter, and once you do that, the equation you have will look something like this. So y equals negative 2600x, and then plus 34,400. So this is your slope, this is your intercept. So now that you've got those 2 equations, you want to figure out where do they intersect. Because once you know where they intersect, then you can figure out that based on your models, you can determine the point where your income and your expense should be equal. Because again, this blue one's your income, this green one's your expenses. So to figure this out, first step, plug both these equations into your y equals screen so you can graph them. Then graph them. When you do, you'll probably see a vertical line because these slopes are 2,000 and negative 2,600. So these slopes are so ridiculous, they're going to look like a wall to you, so you have to change your view. So hit zoom. The 0 option, the 10th option is zoom fit. Press that. Now hit enter there, and then you'll see a better graph. That'll look something like this. The zoom fit option just gets a viewing window that lets you see everything you graph over here. So it basically zooms out a lot on the y axis. Okay, now to find the intersection. So to find the intersection, just hit second, calculate. The 5th option is intersect. Right before we did minimum maximum for absolute value vertexes or vertices, now we want the intersection of these 2 lines. Hit the 5th option, then press enter 3 times. And when you do that, you get your answer. So there's x and there's y when these 2 lines intersect. That's the point right there, which means your answer is, we'll round to the nearest hundredth, 9.32 and 10,152.17. So what that means to the problem is that it's going to be at about 9 months where income equals expense. right? And that's what the income should be, about just a little over 10 grand. So going back to the original problem, way up here, so the month in which income will equal expenses, it's going to be somewhere in the 9th month. The 9th month, then, of course, you all know, is September. So that's the final answer. So this video was 20.5 minutes. I apologize for length, but I got a lot to cover here. So now you guys should be ahead of the game for Thursday in class. So thanks for watching, guys, and I'll see you in class. Hopefully your test went well. Bye now.